Hello, Algebra 1 students. I hope you're having a great day, and I hope that you have been understanding our lessons in this unit so far, graphing systems of equations. So far, you have practiced graphing single lines and graphing a system of two lines to check where they intersect. Today, we're going to be dealing with everyone's favorite word problems. Your target today is that you can write and graph a system of equations that best models a problem and explain what the point of intersection means on the graph. Please write that in your notebook as well as today's date, and maybe note to yourself that what you're putting in your notebook is coming from word problems. You'll notice that I have the Desmos calculator open on the side because I'm going to be showing you today how you can get the Desmos calculator to do the graphing for you. Now that we've practiced it by hand on whiteboards and notebooks, and you have practiced it on Delta, I'm going to show you how Desmos can work for you. So let's start off with this scenario. Today, the temperature in New York is -1 degrees Fahrenheit and is expected to rise 3 degrees per day. It is 6 degrees Fahrenheit in Alaska and expected to fall 1 degree every 2 days. What can you tell from the graph of this scenario? So that is a very broad question. What can you tell from the graph of this scenario? So one of the things that we're going to do is determine what are the things that we can tell from the graph. And we'll get to that. We first have to make a graph. So let's talk about New York. It says New York initial value. Well, it tells me in the story that New York today is -1 degree. So that is my initial value. The rate of change is 3 degrees per day. So that is 3 degrees per 1 day, or you could just put a 3, which I'm going to do in the equation. This is my M, rate of change. This is my B, -1. My equation will be y equals 3x minus 1. Now let's talk about Alaska. It says it's 6 degrees in Alaska and expected to fall. That sounds like a slope or rate of change word, 1 degree every 2 days. So we're going to start off with 6 degrees. That is my initial value, 6 degrees. And it is expected to fall 1 degree every 2 days. So 1 degree every 2 days. It is falling, so I'm going to put a negative in front of that. And my equation is y equals -1/2 x mx plus 6. Now, I'm coming over here to the Desmos calculator, and I'm going to show you what it can do for you. Now, I've got mine zoomed in a little bit because my screen is squished over. And I'll be showing you throughout this video what to do if the whole graph doesn't show up. So y equals 3x minus 1. It made the graph for me, just like it did when we were doing line of best fit. Y equals -1/2 x plus 6. Whoops, that was weird. I do need to come up out of that fraction. X plus 6. There we go. So you can see over on the Desmos calculator that we have the two lines crossing. You can put your mouse over where they cross and it gives you the ordered pair 2, 5. What does 2, 5 mean? And underlined in pink, what can you tell from the graph of this scenario? Well, you can tell a few things. The first one I have at the top with this little guy that's supposed to look like he's not very strong, he's weak. You could just say after 2 days, the temperature in both cities will be 5 degrees. That's what 2, 5 means. You could get a little bit stronger. like this fella here. After 2 days, the temperature in both cities was 5 degrees. Before 2 days, it was colder in New York. After 2 days, it was colder in Alaska. So here's New York, started out at -1. I know the line goes past that because the graph maker doesn't know where we started. -1, and it's going up steadily. And then after 2 days, it passes Alaska. The temperature is continuing to rise, but Alaska starts here at 6, and temperature is going down. And after 2 days, it's lower than New York. So you can tell more than just, oh, they cross at 2.5. It means 2 days, 5 degrees, 2.5. Those are the things we were talking about. So let's look at another scenario. And clear everything off and start from fresh. So here we have a scenario. Jasper and Ben both went bowling last weekend, but not together. Jasper went during open bowling time, paying $4 for shoe rental and $3 per hour. Ben went on family night when each hour was $2 and shoe rental was 6. So they both had to rent shoes and they both had to pay per hour to bowl. As it turned out, they actually played the same number of hours and spent the same amount. How is that possible? Shoes were a different price, bowling was a different price per hour. Well, we can find that out by writing a system of equations, putting them on a graph, which I'm actually going to put on Desmos over here, and find the solution. If we were all in class together, I would put all of these questions up on the whiteboard and you guys would graph these on paper at your desk. So technology and COVID running us together on those two things, you're going to be graphing it on Desmos. So Jasper had to pay $4 up front. The initial value in this story is the shoes. And Ben's initial value up front, his shoes cost $6. The rate of change in this story is the per hour. How much do you pay per hour to bowl? That's the thing that keeps happening over and over. Jasper had to pay $3 every hour, so that was his rate of change, $3 per hour. And Ben had to pay $2 per hour. That was his rate of change. When I write this into an equation, be careful not to put y equals 4x plus 3, just because I asked them in that order. Remember, it's mx plus b, so this one is 3x plus 4. And for Ben, it's y equals 2x plus 6. Once you get this information, you'll go over to Desmos and graph it. All right, so I've put my two equations in, and Desmos has drawn the two lines, and it looks like they're crossing right here. So I'm going to click here, and it looks like that's 210. So apparently they both bowled for 2 hours, and it cost them $10. Now I can actually check that. I can take the top equation and I can put 2 in for x. So I can do 3 times 2 plus 4. And that is 6 plus 4, which is 10. I can also put 2 in for x for this one. 2 times 2 plus 6, which is 4 plus 6, which is 10. So when they both bowl 2 hours, they both cost $10. That's what this is when I see where the two lines cross right here at 210. It's telling me after 2 hours, they both pay $10. So in pink, I've written after 2 hours for both, it was $10. That's how I would write a sentence with words because word problems get word answers. You can see I've already filled in the blanks with the same stuff I had on the previous page, but I have another bonus question down here that you can get from the graph. Which night is better for bowling only 1 hour? And I think most people would agree better means less money. Which night is better for bowling only 1 hour? So I come to my graph right here where the 1 hour is, and I go up, and this red line is lower than the blue line at 1 hour. So Jasper is the one who paid less. Jasper went open bowling time. So which night is better? Open bowling is better. So not only can you get numbers off of this, if you have a true life scenario like we do here with open bowling night or family night, you can find out that it's better if you're just going to bowl maybe one game, open bowling is better. If you're going to bowl a bunch of games, you can see that after 2 hours, Ben's line is a little bit lower. So if you're going to bowl a lot, maybe if you're on a league or you're practicing for a team, you might want to go on family night because family night costs less after 2 hours. Okay, I've cleared everything off and now I'm on my third scenario, and we're talking about towing companies. So every once in a while, once you guys own your car, hopefully it doesn't happen often, but it's probably going to happen at least once. You might get a flat tire or something happens to your engine or the road's icy. So you might need to have your car towed. So here we go. Compare these towing companies by writing an equation and graphing the charge of a tow based on the number of miles you need to be taken. So if the auto shop tows you, they charge $15 to come pick you up. And in real life, that's low. They're probably going to charge you something like $49.95 just to come out. But for our practice in algebra, we say 15 to come pick you up and 50 cents a mile for the tow. So initially, you have to pay auto shop $15. And then the rate of change is every mile you go is 50 cents. I'm going to go ahead and put the equation for that. Y equals mx plus b. So m is 0.50. You may also just put 0.5. 0.50x plus 15. Oh, I've made it to the middle of my screen. Okay, so I got that to fit in. That is squished up 0.50x plus 15. Then we're going to talk about Benny's Wrecker Service. Benny's Wrecker Service charges $10 to come pick you up. So that's the initial value just for Benny to come pick up your car. You got to pay him $10 just to show up. And 75 cents a mile for the tow. So that's the rate of change, 75 cents. That would be the slope of the line, 0.75. So let me squeeze this one in here. Y equals 0.75x plus 10. So $10 no matter what, 75 cents a mile. And the auto shop is $15 no matter what, but only 50 cents a mile. So I am going to come over to Desmos now and put those equations in. All right, so I have those two on the graph, but this is the first time this has happened. I can't actually see on the screen I'm on right now where they cross. You have options. You can maximize the screen, so possibly you can see it. What I'm going to do is I'm going to click and hold, and then, whoops, not on the line, click and hold on the graph and pull the graph down until I can see where they cross. So they are crossing right where my arrow is. That looks like that point is 2025. So I'm going to remember 2025 and decide what does that mean? What does 2025 mean for this scenario? With these two lines drawn, what does 2025 mean? Here's what it means. And I've taken the graph, I've put it over here, It means that at 20 miles, both companies cost $25. So if you knew you had to go exactly 20 miles, it wouldn't matter who you called. But which company is better if you need to go 30 miles? So take a look at the graph. Pay close attention to which line's going up more and which line seems to be coming leveling off, so to speak, compared to the other company. And which company would be better if you needed to go 30 miles? So here's 30 miles, and I just travel up to my two lines. And at 30 miles, it's right here or right here. The higher up is more expensive, the lower is less expensive, which is my red line. So Benny's is better if I need to go 30 miles. The auto shop's better if I need to go less than 20 miles. So depending on where you need to go, you would calculate which auto shop, which tow company would be better. I totally understand that you're not going to sit in the back of your car, the back of your truck, and draw out this graph and put these scenarios. You're probably just going to grab a calculator and say, all right, $15. I got to go 20 miles, 50 cents times 20 miles plus $15. That's what you're going to do if you are concerned with the cost of the tow truck. If you're just concerned with getting to safety, you're going to call whoever can come first. However, this is used as a real life scenario that you might encounter. You might encounter having to have a car towed. And this is just showing that there is a difference. You might say the upfront cost is what makes the difference to you. Upfront is 15 or 10. Or you might take the time to figure out which one's better depending on how far you need to go. The further you need to go in this scenario, Benny's is the better deal. All right, guys, I've cleared everything, and now I'm on the last scenario that I want to look at with you. And when I first looked at this one, I thought, oh, that looks like so much longer of a story. So if you had it on paper, I would tell you to underline stuff. But since you don't have it on paper, you should write down the things that are important as you read. And so I'm going to demonstrate that for you. I'm going to use this graph area to write some important stuff down, since I know I'm going to use the Desmos graph to actually do my graphing. So in this area, I'm going to write down some stuff like I would in my notebook. So reading along, it says, your school is donating items to the local food pantry. Your homeroom is having a competition to see who will donate the most items. You have already donated 14 items. So you might put you, or you might put me, depending on how you're reading the story. Already donated 14. So 14 already. And I'm going to donate 3 more each week. So 3 more each week. So that's what's important about you or me as you're reading it. Then it says, so I'm going to put that in parentheses, already looked at that part. Now it says your friend has already collected 8 items and plans to collect 5 more items each week. So I'm going to use a different color. Your friend has already collected 8 items and will get 5 more each week. So in your notebook, maybe you write friend, already 8, already, and 5 more each week. Once you have that important information, you don't stop, you keep reading. How many weeks will it take for both of you to have collected the same amount? So I'm looking for how many weeks, and I know that I'm doing 5 more each week and 3 more each week. So I should probably be able to figure out the weeks. And it says, how much will each of you have collected at that time? How much or how many it should say, I've already got 14, friends already got 8. So I can probably figure out how much each one of us will have total after we have the same amount. So Thinking again, the initial value for me is 14. And my rate of change is that I'm going to get 3 more per week. So the equation for that is 3x plus 14. The friend has 8 already. They're going to donate 5 per week. And the equation for the friend is 5x plus 8. So go ahead and put that on your Desmos calculator and see if you can answer this question. How many weeks will it take? How much will each one of you collect by that time? Put it on your Desmos calculator. You're looking for where the lines cross. Okay, so by now you've answered a couple of questions. I'm coming back to, I have typed in my 2 equations, but I do not see them. So I'm just going to pull my graph around until I see it. And it looks like these 2 lines are crossing at 323, which means in 3 weeks, how many weeks? 3 weeks. How much will you collect? 23. Again, when the 2 lines cross at 323 over here, they're crossing at 323. That means, to answer my question over here, that how many weeks is 3 weeks? How much will we have collected? 23 items each. So I have that summarized on the next page. I've taken the graph. In 3 weeks, you'll both have 23 items. Here's all of the initial value and rate of change information. And then I've got a bonus question. Who will have collected the most in 5 weeks? So take a look at the graph because 5, the line doesn't go to there. But what do you predict? Who will have collected the most in 5 weeks? Hopefully you notice that the blue line is going up faster. So in 5 weeks, your friend would have collected more. And you can figure out how many that is by plugging in 5 in the place of x right here. 5 times 5 is 25. 25 plus 8 is 33. So your friend, it didn't ask you this, but you can figure out that your friend would have 33 items in 5 weeks. And you would only have 3 times 3 times 5 is 15. And 15 plus 14 would only give you 29 items. I'm just plugging in 5 right there for x and 5 right here for x. You can predict that even if the graph doesn't go all the way, but you can tell, I hope that you can tell that this blue line is going up pretty fast and the red or pink line is going to level off compared to the other line, not really level off. So review your notes, make sure your notes make sense to you. Play parts of the video again if you need to make sure that everything makes sense that's in your notebook. Tomorrow you will have the same type of question on quizzes, so you're going to need some good notes to look back at.